So, for the next concept, we're gonna start with a little riddle. So, we have we have this girl named Lucy. So, Lucy is a math grad who majored in statistics in college, and she aced all her statistics classes and graduated at the top of her class. So there, so the question, my question for you guys is that, what is more likely? Is Lucy? What is more likely, that Lucy is a painter, or Lucy is a painter who plays poker on the side? So I'll give you pause this video to to help you think. So the answer is that the more probable reason is the more probable scenario is that Lucy is a painter. And the thing with this riddle is that people usually answer the most probable thing is that Lucy is a painter who plays poker. 80% of the time, people say that she's a painter who plays poker. And it's because the information we're given is that she's a math grad, and she's particularly good at it. But from a statistical point of view, there are more added, the fact that she is a painter. Let's say a ballpark figure is 30% chance that she's a painter. But the uh, the chance that she's a painter who plays poker and is significantly lower, around maybe 15 or 10%, because there are two things you have to account for: that she is a painter and that she plays poker. And the thing here is that because of our perceptions, our preconceived judgments, we think that it's more likely that she is a painter who plays poker. However, that is just statistically, logically incorrect. And this brings us to my next topic is the role of inference in perception. So, this the whole gist of this is that we use physical and semantic regularities to infer a scene, just like in the scene of Lucy, where we're given these pieces of information about her, and we use our semantic regularities to form our answer. And since she is a math major, we saw it more likely. Most people saw it likely that she is a painter who plays poker. And there are two concepts under this role of inference perception: the theory of unconscious inference and the likelihood principle. The theory of unconscious inference was conceptualized by this guy, Helmholtz, and says that our perceptions are the result of unconscious assumptions about the environment. So sometimes what this does is that sometimes we make judgments on things unconsciously, like it's preloaded in our minds. And likelihood principle states that our perceptions of objects and scenes tend to lean towards the perception that is more likely. So this is like the Gestalt principle of pragnance, in a way that we lean towards the more likely, more simple answer than the more complex answer that requires a lot of thinking un, uh, to arrive to. So we determine which object caused a particular stimulation, and this is solved by a process which the observer brings his or her knowledge to determine the environment. So as I stated earlier, we use physical and semantic regularities to infer a scene, and we use and this is and when they converge, this is how we create our perceptions of everyday things. And those three concepts: the theory of unconscious inference, likelihood principle, and the, and and determining which object caused a particular pattern of stimulation is seen in this in the next slide, the Mandela effect. The Mandela effect is essentially there are things that we thought were but actually weren't. For example, there is no double stuffed Oreo with two F's. There's only double stuffed with one F. And the color chartreuse is actually this one. It's actually sorry. The color chartreuse is actually this one and not this one. Even I honestly personally thought this was chartreuse, not this. And also, it's Fruit Loops and not Fruit loops. So here we see the theory of unconscious inference very explicitly. Is because we really do not think about these things hardly in our everyday lives, and because of this we have our own perceptions of these things. So we thought that double stuff is spelled with two F's, chartreuse is pink rather than greenish in color, and and the spelling of Fruit Loops. And this becomes the and in turn it becomes the more likely thing when we have our preconceived notions unconsciously. We set forth our when we're asked when we're asked about these things, we're going we're going to think about this instead of us. We're going to think about this instead of this, or this or this instead of this. So in a way, our perceptions can be our perceptions can be wrong, especially when we do not really think about it and we don't really ponder about it. But these things are trivial, slightly trivial, but there's some things that cannot be taken and on the surface area that we have to think about very deeply. So next is connecting neural activity and object perception. So brain activity and identifying pictures. So this is the study done by Grill Specter in 2004. It showed a picture of Harrison Ford. Then it was masked. Then people were asked what they saw, what was the stimulus, and it was very interesting that, and they found that this in this graph you could see that if they identified correctly that it was Harrison Ford, the signal would be very high. And even if, but what's interesting as well is that even if they did not recognize it, but they know that they saw a face, there would still be a relatively high fMRI signal. But uh, logically, when they didn't see anything, like the random texture, so maybe they saw the random texture, there was no signal, like almost flatline. And it shows that what the how it shows that how we see objects is very is very psychological as well as very physiological, in a way that our brain, our like for example, our hardware, which is the brain, and software work together in unison, and it has to be, and then that's just the way it's supposed to be in order for our perceptual capacities to work at the level that we want to be at a level. So yeah, the level of brain activity is directly proportional to whether or not a stimulus is perceived. Shows that how the brain reacts to the stimulus as it is presented. Facts our ability to identify the stimulus. So as you can see, the higher the stimulus, specific the more specific the observer's response was. So the next one is binocular rivalry. So when each eye gets different images and perceives only what is on the left eye on the right eye. So there's so binocular rivalry is essentially when there are two different images. So you get pretend a triangle and a circle are being shown, but the triangle's only being shown to your right eye, not to your left, and the circle's being shown to your left eye but not the right. There occurs binocular rivalry, wherein it can only focus on one shape but not both shapes. So